Hi, this is Miss Black, and this is Open Campus, and we are now in Module 8. And Module 8, we're going to change gears. We've been working on solving just one type of equation at a time, and now we're going to solve a system of equations. And that implies we're not going to have one equation now, we're going to have two. So let's go to our notes. If you look up here, we have a linear equation. Now we're going to be solving a system which requires we're going to have two linear equations. So to solve a system, not only is our equation going to have the variable x, it's also going to have the variable y. So right now in Module 8a, we're going to solve a system of linear equations, which means we're going to have two linear equations that each have an x and each have a y. They're still linear because they're to the first power. What happens is when you solve a system of linear equations, you get a solution for both x and y. Well, if you know your algebra, you know when you have an x and a y value, that plots a point on a graph. So what we're technically doing in this module is, without drawing a picture of the equations, we're finding out where they're going to intersect. We're going to find the x value and the y value. And there's two ways to do this. We're going to take our Algebra 1 skills and we're going to talk about substitution and the addition method. So, if you look here, you know what the word substitute means. It means to replace. What's going to happen today is we're going to replace a variable not with a number, but with another variable expression. So let's go to the whiteboard. Okay, ladies and gentlemen, if you look here, we have a system of linear equations. They both have an x, they both have a y, and both the x and the y are to the first power. So that's what makes them linear. And linear still means we'll have one solution for x. Now we're going to have also one solution for y. What we want to do is we want to take these two equations and put them together. We want to make them become one equation with all the same variable. Because right now, as you know, you can't take an equation that has an x and a y and solve it and get a number. So one way we could put these two equations together is called substitution. Substitution means to replace something with what it equals. You do substitution in your everyday life. When you exchange a dollar bill for 4 quarters, you're doing a substitution. They may not look the same, but they have the same meaning, the same value. That's what we're going to do here. Now, it would be obvious. If I covered that up and that just said y equals 2, you would all rock and roll. You would say replace y with the number 2. Instead of replacing the variable with a number, we're going to replace the variable with an algebra expression, with a different variable. So if you look here, we know what y equals. Y equals 2x minus 9. We can do a substitution. Wherever we see a y, we're going to replace it with 2x minus 9. And I'm going to draw an arrow for where it's going to go. This expression is going to replace this variable. So we're going to rewrite this equation now. It now becomes x plus 3, but instead of writing the y, we're going to replace it with the 2x minus 9. And because these variable and this number are side by side, that's connected by multiplication, is 8. That's what substitution means. Take your variable, cover it up, and replace it what it equals. Now if you look, this equation has all x's in it. It's something you can solve. We're back to Algebra 1, a linear equation. So what are we going to do first? That's right, we're going to distribute the 3. So 3 times 2x is 6x. We're going to distribute the 3. 3 times negative 9 is negative 27, equals 8. Then we're going to collect our like terms, CLT. 1x and 6x is 7x, minus 27 equals 8. We're going to move our constants to the right. So we're going to add 27. 7x equals 35. We're going to divide by 7. And there's our solution. X is 5. So if you look, by taking the two equations and putting them together by substitution, you formed a linear equation, an Algebra 1 equation you know how to solve. Now you're not done. This equations, both of them, did not just have x's. They also had y's. So now that you know x is a number, you're going to do substitution. But this is an easy substitution. You're going to take that number 5 and go back to one of the equations on top and replace it. Now, math is all about thinking, how can I get the answer quick? What's the most efficient way to do this? So if you look, it doesn't matter which of these equations you use to get the y value, but which one would be easier? Very good. It would be the one that I already have circled. So that's why I always circle it. It does a visual for me. It reminds me that this is what I'm substituting in, and it also reminds me where to go back and get the other solution. So now we're going to rewrite this. We have y equals 2, but instead of writing x, we're going to write 5 minus 9. And now we'll work that out. Y equals 10 minus 9, y equals 1. The final point here is to make is that when you solve a system, because you're getting a value for x and a value for y, in algebra, an x and a y is an ordered pair, a point on a graph paper. So you must write your final answer as an ordered pair. And every point, every ordered pair must be written in parentheses. And x always goes first and y goes separate. So that would be your solution. So when we're in this module 8 and we're solving systems, you're going to get a solution for both x and y, and it must be written as an ordered pair. So far, so good? Great. Let's move on to the second example. Here is my system. X equals 9 minus 2y. X plus 2y equals 13. It's two equations. They both have an x. They both have a y to the first power. That's why it's linear. We'll have one solution for x, one solution for y. The easiest way to put these equations together is doing substitution. What does substitution mean to do? That's right. It means to replace. So the question here is, which variable do you replace? Well, it's very obvious. You replace the variable that is isolated, because the one that's all by itself, you know what it equals. So if you look, who are we replacing? Are we replacing y this time, or is it going to be x? Very good. It's going to be x. This says x equals. If I covered that up and said x equals 9, you would not have a problem. You would replace x with 9. So who cares that it has a letter behind it? X is equivalent to 9 minus 2y. So that's going to be our substitution. Wherever we see the letter x, we're going to put this expression. I'm going to draw an arrow to tell myself where it goes. It's going to go right there. So now I'm going to rewrite that equation. So I'm going to cover up the x because I'm replacing it, and I'm going to put 9 minus 2y. Then I'll write the rest of the equation. Plus 2y equals 13. Now you just have one equation to solve, and because you have the same variable, you can actually solve it. Well, what do? We have no parentheses, no fractions, no decimals. Let's collect like terms. Oh, wow. What happens with negative 2y and positive 2y? That's right. They're additive inverses. They're opposites. And when you add them, they make no y's. So do we need to write that? No. So we're going to bring down our 9, and on our right side is 13. Now, we've seen this before. We've already talked about little Bo Peep losing her sheep. Well, sometimes when you solve, you'll lose a variable. When you lose a variable, you have to know this. You're either going to have a true or false statement. How do you decide? You read. 9 equals 13. That is false. What you have to have memorized from our very beginning modules, module 1, is what does it mean when you're solving and you get a false statement? That always means no solution. That means there is no number for x and no number for y that will make both of these equations balance. Okay, you ready to try a more difficult one? Great. So let's get this going. All right. Now we're going to take another system and we're going to do a more difficult one. The reason why this is more difficult, it's going to have the dreaded fractions that you guys don't like. Y equals 2/3 x minus 1. Y equals 1/6 x plus 2. So it's a system. You have two equations. It's linear. They both have x and y to the first power. The problem is you got to condense them. You got to make one equation. So we're going to do substitution. So the first thing is you know what to substitute. You'll have that variable isolated. What variable is isolated in both of these equations? Very good. It's y. Y equals y equals. So it doesn't matter if you take this whole expression and put it here, or take this expression and put it up here. You're going to replace the variable y. So I'm going to circle. That's what y equals, and it's going to go in that spot. So now I'll do my substitution. I'll do my exchange. This is like everyday life. You're at the soda machine. You have a dollar bill. It won't take it. You ask the person next to you for the 4 quarters. You're not going to get to keep your dollar and get the 4 quarters. You're going to have to give away your dollar to get the 4 quarters. That's what you're doing here. You're giving away the y to put this expression. So you write 2/3 x minus 1 equals 1/6 x plus 2. Okay, we're back to module 1. If you're like me, do we like fractions? No way. So how do you get rid of fractions? Do you remember? That's right, you use the LCD. What is the LCD of 3 and 6? 6, very good. We're going to do that by multiplication. So I multiply every term by 6, because we've already discussed this. Everything's got to balance in an equation. When you multiply, it goes to everything. 3 goes into 6 twice, so 2 times 2x is 4x. There is no division bar here, so we multiply. -6 times 1, -6. 6 divided by 6 cancels out, you get 1x. 2 times 6 is 12. Look at that. You're back to Algebra 1, a simple linear equation. Variables move to the left. 3x minus 6 equals 12. Numbers move to the right. Add 6. 3x equals 18. We're going to divide by 3. And what's our solution going to be? It's going to be x equals 6. So far, so good? Are you done? No way. Each one of these equations has an x and a y, so when you solve a system, you must have an x and a y. Does it matter which equation I go back and get the y with? Not at all. I'm a creature of habit, and what I circled is where I go back. So I'm going to go back and use that equation. I'm going to write y equals 2/3. I'm substituting for x, 6 minus 1. Now I'm going to do my arithmetic. 3 goes into 6 twice. 2 times 2 is 4. 4 minus 1 is 3. I'm going to prove to you it doesn't matter. If I use this other equation, I would get the same y value. I'll show you. If I write y equals 1/6, instead of writing x, we're replacing it with 6 plus 2. Y equals 6 divided by 6 cancels. That leaves us 1 plus 2, which is 3. So see, it doesn't matter which equation you go back to get the other value. The most important thing is you have to write this as an ordered pair, a point. And x goes first. It's in alphabetical order 6 with a comma, and y goes second. So without drawing a picture, we found out where these two equations would intersect. So far, so good? Great. Let's go back to the notes. Okay. So if we go back to the notes now that we've talked about substitution, what happens if I tell you there's another way? Okay? There's another method that does the same job as substitution, and it's called the addition method. Some of you may have had it taught to you as the elimination method. I don't care which name you refer to it by, it means the same thing. I call it the addition method because you're physically going to do what you did in 2nd grade. You are going to add the equations together. And we already know the rules. You can only add together like terms. So we're going to add the x's with the x's, the y's with the y's, and the constants with the constants. But there's a trick to this, and it's real simple. When you do the addition method, not only do you want to add the equations together, you want to guarantee that one of the variables cancels. It disappears. Well, the only way for a variable to cancel is if it was its opposite. It's additive inverse. So to do the addition method is like doing second grade math. You're going to line the equations up with their like terms. You want to add them together. But before you add them, you got to make sure one of your variables is the additive inverse, the opposite. If it's not, we're going to show you how to make it the opposite. Okay? The steps are real simple. You add them together. When you add them together, one variable is going to cancel out. You'll solve your equation, and then you'll use substitution to get the other variable. Let's try some. Let's go to the board. All right, if you look up here, I have two systems. Here's the first one. X plus y equals 1, x minus y equals 3. Okay? Just so you know, when the x and y are on the same side, that was called standard form in Algebra 1. What we're going to do here to solve is we're going to add these. We don't want to do substitution because if you look, do you have x equals by itself? No. Do you have y equals by itself? No. So why do that extra work? The addition method is very simple. All you want to do is add up the equations. So I'm going to put a plus sign because I'm going to add them. Here's the problem. You can only add if you're guaranteed one of your variables is going to disappear. You need an opposite, an additive inverse. Are the x's opposites? No. What's x plus x? That's going to still be 2x. Are your y's opposite? Yes. A positive y and a negative y are your additive inverses. So when you add them, they're going to cancel. And that's how you do the addition method. You line the equations up, and you make sure something's going to cancel. So we're ready to add. X plus x is 2x. Y plus negative y would make nothing. It would cancel. 1 plus 3 is 4. Now look at that. What a simple linear equation. We can solve this. Divide by 2, x equals 2. Are you done? No, you're not. You got to go get the solution. Does it matter which equation we pick? Good. No, it doesn't. I'm just going to pick the top one. So I'm going to write it. X plus y equals 1. Make sure you copy correctly. I'm going to replace x with 2. So this is 2 plus y equals 1. And then I'm going to solve my linear equation. And I'm going to get y equals negative 1. And then how do you write your final answer? Very good. Always, always, always as an ordered pair. So the x value is 2, the y value is negative 1. See how easy that was? So addition is a great method. Now, this one was very simple because we already had our opposite, our additive inverse. Let's go to our second one. Let's look here. Do you have an opposite? No, you don't. 3x and 2x are not going to cancel out and make 0. Because if we add 3x and 2x, we get 5x. And everybody look closely. Negative 4y and positive 3y are not opposites. I know one's positive and one's negative, but they won't cancel out and make 0. Negative 4 plus 3 is a negative 1. So you would still have a y here. So this is not going to work right now. You can't add it till you're guaranteed one of the variables is going to cancel. So now you're in the driver's seat. You make a big girl and big boy decision. You decide which variable would you like to cancel. Would you like the x's or would you like the y's? I don't care. It doesn't matter to me. I agree with you though. The y's would be easier because this is positive and negative and that's going to cancel. So the problem here is to make these y's cancel, they have to have the same coefficient. So we need a number in common with 4 and 3. Do you know what number I'm talking about? A number in common is like getting the common denominator. But we're not doing fractions here, so this was called in 3rd grade the common multiple. What number is in common with 4 and 3? We want the least common multiple of 4 and 3, which is 12. So you can't call it LCD because there are no fractions here. But the concept of getting a common number is called the multiple. Now that's easy. We know how to make this a 12. We'd multiply it by 3. The reason why I put in parentheses around the whole equation is we all know this. You just can't multiply this term by 3. You've got to multiply everybody by 3. So now we're using our distributive property, and we get 9x minus 12y equals 33. Okay, this is not a 12. This is a 3. So to make this a 12, we're going to have to multiply by 4. I'm putting parentheses around it because I got to multiply everybody by 4. So we're going to distribute again. 4 times 2x is 8x. 4 times 3y is 12y. 4 times negative 4 is negative 16. Now, everybody look closely. Do you see your additive inverse, your opposite? Yep. So now we can add. 9x and 8x is 17x. Negative 12y and positive 12y would make 0. It cancels. 33 plus a negative 16 is 17. Look at that. You're back to algebra 1. Divide by 17, x equals 1. So that's the trick. If it's not already an opposite, you can make it an opposite by doing multiplication. Now, are we done? No way. We got x. We still got to get y. Does it matter which original equation we go back to? No. Remember, we always go back to originals. So I'm going to pick the first one. So I'm going to write that. I have 3x minus 4y equals 11. I'm going to replace x with 1. So 3 times 1 minus 4y equals 11. We multiply to get rid of parentheses. We're going to move to 3 by subtracting. Watch your signs. That's a negative 4y. 11 minus 3 is 8. We divide by negative 4. And y is negative 2. How do we write the final answer? Good. With every system, we write it as an ordered pair. 1 comma negative 2. See that? Pretty cool, right? All right, I think we got one more system, so let's go look at it in our notes. All right, our last system. 4x plus 6y equals 8. 6x plus 9y equals 12. Okay, why are we calling this a system today? Very good, because we have 2 equations, not 1. And we got to solve for both x and y. Now, let's talk. What's going to happen is you may be told, do this by substitution. You may be told, do this by addition method, which is also called elimination, because when you add, you're eliminating a variable. But a lot of times you're not told. You get to make the decision which way to work this. Now, if you look very closely, this system would not be a good choice for substitution. Because think about it. Do you have a variable isolated? You don't. There's no x equals. There's no y equals. Well, even think about this. Could you get x by itself? Well, in order to get x by itself here, you'd have to divide by 4. Well, we all know this. Does everything divide nicely in math? No. Does 6 divide nicely by 4? No, that would make a fraction. So that's why when I look at this system, I would say no way substitution. Substitution means I need a variable isolated. There is no variable isolated, nor would I want to get any of these variables isolated because they have all these coefficients in front and I'd have to divide and I make fractions. So this is a clear candidate to do the addition method. But we got a problem. You just can't go ahead and add. You've got to be guaranteed a variable cancels. So again, will 4x and 6x cancel right now if you add it? No, that'll make 10x. Will 6y and 9y cancel right now if you add it? No, that'll make 15y. So you got to make the decision. I can't make it for you. Your homework can't make it for you. You decide, do you want to get the x's or y's, the opposite? Let's do the x's this time. So again, let's look. We have a 4 and a 6. We need a number in common. That's called your LCM. What is your least common multiple of 4 and 6? Well, if you know your times tables, it would be 12. So what we got to do is we've got to make both of these become a 12. So we're going to use multiplication. So what do you multiply to 4 to make a 12? 3. Now we're going to multiply the whole equation by 3 to always keep our balance. So 3 times 4x is 12x. 3 times 6y is 18y. 3 times 8 is 24. Now we have to come down here. We said we're going to make the variable x 12. So to make a 6 to 12, we're going to have to multiply by 2. But you have to pay attention. If this 12 is positive, in order to cancel, this 12 has to be negative. So we're going to have to multiply by negative 2. So negative 2 times 6x is negative 12x. Negative 2 times 9y is negative 18y. Negative 2 times 12 is negative 24. Now your x's are the opposites. So we're ready to add. 12x minus 12x makes nothing. Uh-oh. 18y plus a negative 18y makes nothing. We talked about this. You never write an equal sign and leave a side of the equation blank. If everything canceled on this side, we're left with nothing. On the right side, 24 minus 24 is nothing. Little Bo Peep has lost her sheep. You have lost your variable again. So look, everybody, read that out loud. What does it say? It says 0 equals 0. Is that a true statement or a false statement? That is true. So think about it. A minute ago, false meant there was no solution. True means there's not one ordered pair, one point these have in common. There are many points. So we would say true means there are an infinite amount of solutions. So that's important. When you solve a system of linear equations, you're either going to solve it, get a value for x and y, which is one solution. You're going to solve it, get a false statement, which means there is no solution. Or you're going to solve it, get a true statement, which means there's an infinite amount of solutions. Now, visually speaking, what did you just do? Technically, we could have graphed these equations, saw they made pictures of lines, and we could have talked about it. If you draw two lines, they can intersect at one point. That's what happens when you do get an x and a y value. When you solve and get an x and a y number, you're saying they intersect at one place. But when you draw lines, they don't have to intersect. Here are two lines I'm drawing. They're not intersecting. They are parallel to each other. If they're parallel, they do not have a point of intersection. That's what the no solution means. So when you get no solution, you're saying if I drew a picture, these lines would be parallel. They would not touch. If you get, when you're solving a true statement, what's happening is you're saying, when I draw the first line and I draw the second line, they're not intersecting in one place. They're intersecting in all the places. They're actually falling on top of each other. And there are many points that they would have in common. So that's your visual for what you just did on paper. You found without drawing, if you drew two lines, how many places could they intersect? Okay, I'll see you in the next module.